Good day to you. This is Anagalactic in our first series on the number system and mathematics for physics and other forms of science. Numbers have functionality. They perform tasks in various contexts. In order to get into mathematics, which is numbers with operators, we arrived at day 2 of John Conway's famous binary tree that describes visually the definition of the linear number system. On day 0, we got the split 0, which is the structure. On day 1, we got 1 and negative 1, and each day produces a pair. This is called a tree, and the first split is to get positive 1 and negative 1. And then we learned that we can discard the negative numbers. Also, we discard the 0. And we now have a new tree that has a new root that is just one number. It is the number 1. And that splits. And that's the most important split in the tree, is the split from 1 to the next pair of numbers. Of course, one of the numbers is going to be 2, but that's just the beginning. And on day 1, you get the index of linear space, which is 1. And if you want to use distance, then you need 0. And so it's very important to begin at 0 to realize its importance and also its limitation. So now on day 2, we discover it now splits, and in this direction you get 2. That one branch is the counting numbers itself. But when 1 splits off to 2, there is a second number that splits off in the other direction. And the question that we asked yesterday, and John answered it for us, but it's worthwhile to just take a moment to try to guess what number would be paired with 2. I believe the first instinct would be to answer negative 2, but actually all the negative numbers are in the other branch. So these are all positive numbers. Of course, beginning at 1, that's the smallest counter. So what's after 1? Well, traditionally, we say that it's 2 if you're using counters. That is, integers, whole, or natural. All 4 terms are exactly synonymous. You begin at 1. Plus means going off to the right. Minus means going off to the left. It's a direction sign. It goes in the opposite direction. There's no such thing as a negative direction. There can only be a positive direction. But once you notice that those are 2 directions, you realize that the operator brings them to the middle point. It balances them. Left and right are balanced on a specific number. That number is called the identity number. There is another identity number. This not 0. So you have the object is the line. The operator is add. And the identity is 0. It's the center number. Do the same thing to make the multiplicative identity on day 2. You have 2. That's one of the numbers that's generated from 1. What's the other number? It's the reciprocal of 2. We call it 1/2. We also say 1 over 2. We also say 1 divided by 2. But the right way to say it, although it is synonymous, it's 1 proportion to. You'll notice that those are in a specific order. What is the relationship between those 2 proportions? 2 to 1 and 1 to 2. They are reciprocal. It's a 4-part number, where on one diagonal is a number, and on the other diagonal is another number. And so it's only 2 counters. In this case, the counters are the first two counters, 1 and 2. You could also say that 2 proportion 1 multiplied by 1 proportion 2 yields 1 to 1 proportionality. Day 2 of John Horton Conway's Surreal number system. When you get the next two numbers from 1, it's 1 over 2 and 2 over 1. And those two numbers multiply to 1. Can you do that on the line? No, you cannot. You cannot accomplish that operation in linear space because the numbers that you're using now are no longer one component numbers. All the one component numbers were left behind on day 1. On day 1, we got the first two numbers from the 0, 0 generator. We got 1 with a valence. So on day 0, there's no nothing. There's no operator, there's no object, there's no quantity, there's no direction, there's no relationship, there's no nothing. It's null. But even John did not realize what he actually discovered. Max Planck also made a discovery that he didn't realize what he had discovered. And we'll get to Max Planck in a second because he discovered the physical counting numbers. He did not know that he did that, though. I know it, and I've proved it. So we're converging on that as well. That is Max Planck's discovery of the quantum. We're getting to that. But it begins on day 2 of John Conway's number tree. That when 0 splits, it splits to 1. And when 1 splits, it splits to 2. But what the difference is, no operator, linear operator, spherical operator. Multiply and divide are actually part of the oldest part of the number system. And what we just tracked through day 0 and day 1, that is actually infinitesimally it's insignificant compared to what happens on day 2. Because on day 2 is the birth of the universal numbers. And nobody has ever noticed that. That on day 2, we get the proportional numbers. Those are 2 component numbers. 1 over 2 is not a number. It's 2 numbers. Because up until now, we've only had counters. And 1 and 2 are counters. But when they're put in relationship, they make a new kind of number that is the original number. The tried and true fraction. It's accurate. It's just that it doesn't signify proportionality unless you remind yourself that that's what it is. That 2 over 1 is not a linear number. The first thing you can say is that it's a multiplicative number. Why? Because that's division. And division is simply the inverse of multiplication. So 1 over 2 is simply the multiplicative inverse of 2. And you could call it 1/2 if you want. So it's 1 over 2, comma, 2 over 1. It's multiply. 1 over 2 and 2 over 1 are division numbers that multiply. They are division numbers. Those are called fractions. These 2 fractions multiply to 1. Look at the line. The line is linear numbers. Look at the multiplicative numbers. 2 over 1 times 1 over 2 multiplies to the proportional identity number. Now look at all the numbers on the line. It's completely balanced on 0. It's a split number system with one going this way and one going that way. 1, 2, 3, 4. But it's just one this way, one that way. 2 this way, 2 that way. Infinity this way, infinity that way. Use the operator to get them to the center. Add them to the additive identity, and that balances the system. All the numbers are balanced on 0. What can we say now about identity number 1? The multiplicative identity. Which numbers all multiply to 1? The whole counting numbers. That 2 has another number that makes it one number. Just as 1 and negative 1 add to 0, 2 and 1/2 multiply to 1. 3 and 1/3 multiply to 1. Which direction are those numbers going? For the line, it's 180 degrees, opposite direction. What about these numbers? Which way is 2 going? They're getting bigger. What's the other number doing? 1/2, 1/3. They're getting smaller. How? What's the relationship between 2 and 1/2? They're inverse. You can also say they're reciprocal, but they're also going in opposite directions. How? It's not on the line, because the line is metricized on 1. So the 2 gets bigger from 1, and the 1/2 gets smaller from 1. So 1 is the center number. You notice I'm drawing a circle. Yeah, think about it for a second. What if the circle has a value of 1? That would be the center of a circular spatial system, wouldn't it? Because the straight line is open. It goes to 2 infinities. The circle doesn't go anywhere. The circle is in another space. It's in circular space, not linear space. Now space is made of circles, not lines. If you say that, and you make the circle have a value of 1, then 2 is another circle that's bigger, and 1/2 is a smaller circle inside. So the bigger numbers get bigger in circular space, and the fractions go in toward the center. Can you reach the center? No. You know why? Because you can't reach the edge. Those are the 2 infinities of the universe. Those are universal infinities. They're not linear infinities. They're not plus and minus infinity. They're in and out. And the inner infinity is called the infinitesimal, to the proportion that the outer circle is infinity. That would be the integral. So the integral is the outer boundary of circular space, and the infinitesimal is the inner boundary to the proportion that the outer is the outer boundary. In reality, it's not a circle. It's a sphere. And that is a closed line in real space. A circle is a closed line in flat space. We do not want that. We want the real one. That's the one that we need for physics, is to have a physical 2-component number system for spherical space. And that's 30 minutes. I hope you understand that there's one last step, because you know that on the line, the 2 numbers are polar opposite. What is the geometric relationship between 1/2 and 2? Really? The whole numbers going out fill space, and as the fractions go in and fill the interior of the sphere. Correct? Correct so far. But what is the geometric relationship between those two reciprocal numbers? We can state that the whole numbers make concentric spheres going out. But we cannot say that about what's going apparently in, because there is no interior to that sphere. The sphere has no interior. That's an axiomatic statement that must be proved. I have done so. And so now we have a balanced number system for space-time, because the two numbers, 2 and 1/2, have a mathematical operation that relates them such that they multiply to 1. The way that the 1 and -1 add to 0 is by a linear balancing to the center point on the line. That the 1 and the -1, when they're added together, converge to 0 and cancel. In the spherical number system, all the paired numbers multiply to 1 instead of adding to 0. And therefore, they're perpendicular. They're perpendicular numbers. And that can be proved from the wavelength frequency relationship, which is exactly 2 times 1/2. That is the lowest frequency and the longest wavelength. 1/2 is the largest number less than 1. 2 is the smallest number greater than 1. And so those two numbers are perpendicular. And the only way you can finally see that is by finding out how these numbers behave in physics. The physical numbers. Max Planck discovered the relationship between 2 and 1/2. They multiply to light speed. So we need motion. You can never get motion on a line. A line does not indicate motion, except in polar opposite directions, according to Newton's law of collisions. Now, in the spherical space, as the whole numbers go out, 2, 3, 4, this is 2 over 1, 3 over 1, 4 over 1, these go out and they fill space. There are gaps, aren't there? Yes, there are gaps on the number line, too, between every number. That's what drove, I'll just say, possibly Georg Cantor insane. Is because he was trying to make the number line continuous. That's equivalent to squaring the circle. It's ridiculous to even say that. So he couldn't do it, and there's no such thing as a real number. And there's no such thing as the real number system. It only applies in calculus. But in the universe, you cannot use calculus. The universe does not use calculus. Do you know why you should? It's because every time you use calculus, you throw out a piece of a number. You cannot do that in geometry. You're throwing out a piece of physical reality. If you get it right, this is to get it right. The numbers that are fractional numbers have to be fractions on 1. So it has to be on the surface of the sphere. That is a rotating sphere. It rotates. And that's where the fractional numbers are. They're on the surface of a sphere. To the proportion that the spherical shells fill space, the fractional numbers fill time. And that's enough for one lecture. That's a lot. If you got it, you're now a genius. You're way ahead of physics. You're way ahead of the mathematicians. You have evolved. If you did not get it, don't worry, because in the upcoming lectures, which will be running from the equinox, which was just a few days ago, to the summer solstice, I will be showing all of this to you and the magnificent breakthroughs that this form of geometry enables for physics, mathematics, and education. It's a brand new geometry that's 3,000 years after the first geometry. We've been using lines. It's time to use spheres. I discovered the number system for space-time. We'll be right back. Stay tuned. I hope you're as excited as I am. I'm trying to keep my cool. But I've been holding this in for 2 years. Not holding it in. There are over 450 lectures in the YouTube archive under my channel name. Half of them I've kept public. The others got less than 3 views because I was just starting out. But that's over 200 lectures that you can review anytime you want. I am not going to stop though. I'm going to make this better and better and better, and eventually I will be speaking before public audiences. I am not after money. I'm honest. I want this to be known for the sake of science. This is Anagalactic. We'll be right back.